Hello, college algebra. So what we have here is inverse functions using composition of functions. Okay, so it's our last function operation. We've added, subtracted, multiplied, divide functions. Now we're going to compose them. So that's what this notation is here in the purple. This is function composition, where we're composing f and h. So this reads like this. If we compose f and h, so if f of h of x, if when we do that, that equals x, and then the opposite, when we say h of f of x is also equal to x, if both these things happen, then we can say that f and h are inverse functions. So here's one that we already know to be true. So this is our natural exponential and natural log. So we already know these are inverses because I've told you guys that. But let's do the game. So let's take f, oh crazy, and we're going to put h in there. And then what we're seeing is if this will equal x, okay? So that's what we want to see, if this will happen. So we're going to take f. So here's f down here, e. But instead of putting x, it's telling me to put this in there. Put natural log of x. Okay, so that's what this is. So look what happens when we do that. These guys go away, and that does equal x. So f of h of x did equal x. So that's a check. Then we have to do the opposite of that. And we have to say h of f of x needs to also equal x. So we're going to do the same thing. So now we start with h. H is the first thing we see. So we write it till we get to an x. There's our x. Instead of writing x, we write this. And again, these guys are the same base, so they cancel each other out, and that does equal x. So we get another check. So we just proved that these guys are indeed inverse functions with that algebra. So let's try it again with q and j. So our q and j inverses. So let's see. So q of j of x. Let's see if this equals x. So we're going to put in q, so keep writing it till we get to an x. So 3, oh, got the x there. We're going to write this other function of 1/3 x plus 2. See how that was just this x? And then we're going to add 2 to it. This guy is going to make -1. So we get negative x, distribute to get 6 plus 2. Clearly, this does not equal x. And that's all we have to show. Once one of them doesn't equal x, then we know that they can't be inverses. So in the first one, we saw that it did equal x, and then that's why they were inverse functions. In this composition, we see that when we go to simplify this, it's going to be -x plus 8. That does not equal x, so I don't even need to try the other one. But if it did equal x, then we would want to go and try the j of q of x to make sure that that equaled x as well. Remember, it has to be both. So if one, then and the other, then yes. So the answer is yes or no, and this is how we prove it. So our f and h, yes, the proof was right there. Our q and j inverses, no, here's my proof right here, right? Okay, so that's what we're looking for. A word answer and a mathematical proof. All right, thanks.